All right, and hi everyone. A very good evening to all of you. Just let me know if I'm audible. All right, so wonderful. Okay, so today we are going to do the quant short answer section of the IPMAT 2022 paper. All right, so this paper is the most recent one. So I'm hoping for maximum participation, and I'm hoping that all of you have tried this question paper, already. So today we are on this day, that is 8th of June. We'll do the QA short answer. Tomorrow we'll be doing QA MCQ, and on 10th, that is Saturday, we'll be doing the verbal ability section. All right, so I'm hoping that all of you have gone through the past year question paper and done the solving. Okay, so let's get going and let's see what would be the best methods to attempt this paper. First of all, before we go ahead, I hope all of you read the instructions. The marking scheme was +1 for correct answers, -1 for wrong answers, and no negative marking in the QA essay section, and no marks for unattempted questions. So today we are solving the QA essay. So it will only be +4 for correct answers and no negative marking. Okay. Apart from this, there was a sectional time limit. So 40 minutes for each section. So today's section for us would be 40 minutes only. Okay, so we'll see if we are able to solve the question paper in the stipulated time, or how we should have paced our attempts to be able to solve the questions in 40 minutes. Okay, so let's quickly go ahead. First section, QA short answer, 15 questions, 40 minutes for +4 for every correct, no negative marking for incorrect. So our aim should be that we attempt all questions. Okay, so let's quickly get going. Question number 1. Let P of X denote the power set of set X. If A is the null set, then the number of elements in P of uh, okay, so I'm taking the power set 4 times. Power set of a null set. Okay, so if we are not very confident with this concept, or power set of a null set, then this is something which you would not be able to attempt. Okay. Achha, all right, you are not able to see the screen. Oh, I'm so sorry. Is this visible now? Okay, so we are discussing this. Quick recap. Today we are doing the IPMAT Indore QA short answer section. Then we have MCQ and verbal ability lined up tomorrow and day after. These were the instructions, +4 for correct and no negative marking in the QA short answer. Today we will be solving 15 questions. The sectional time limit for this section was 40 minutes. However, because we'll be discussing, this would go a little overboard. Okay, but accommodate that, and 4 marks for every correct and no negative marking. Okay, so let's quickly get going. Looking at the next thing, that is question number 1. Now, depends on whether you have studied or understood the concept of power set of not or not. For example, if I have the set this 1, then its power set would be a big set which contains sets as its elements. So big set which contains a null set as its element. Basically power set is the set of subsets. So it will have null set as one element, and the other element would be this set itself. So power set is a big set which has sets as its subsets. Oh my god. So what happens if my set A is a null set? If my set A is a null set, that is, it is also denoted this way, then what will be the power set of A? The power set of A would be, and okay, I also know if the set has n elements, power set has 2 to the power n elements. That is the number of subsets, right? So if I have the set A, the power set of A would be a big set which contains the null set. Okay, so a big set which contains this one element. You can clearly see the number of elements over here is 0. Therefore, 2 raised to the power n, it becomes 2 raised to the power 0, that is one element. Right? I hope all of you agree that this power set has one element. Everyone, can you let me know in the chat? This set has one element, that is the null set. Right? Everyone agrees with that? Now, this was the trick over here. What what many people thought, because the set A is a null set, its power set would contain one element only, and many people, answered the question as one. But then this was not correct. Why was this not correct? Is because if I take I just don't have to take one power set. I have to take the power set of power set also. So if I take the power set of A, you'd realize that I have to create a big set which contains all the subsets of this set. Okay, so this set contains one element. One of the subsets would be the null set. The other element would be this set itself, right? And what is this set itself? This set is a set which contains a null set. Okay, now if you keep writing it, it'll start appearing confusing only. But at this point, you had to stop writing and you had to get into the numbers. The first power set had one element. When you took the power set of power set, it contained 2 raised to the power. Now this has one element and I'm taking the power set of that. So therefore it contains 2 raised to the power 1, that is 2 elements. Okay. And this was the turning point, or this was the point where tripping point where you had to understand, as you keep on taking power sets, the power of 2 will keep on increasing. Null set has 0 elements. You took the first power set, it contains one element. You took the second power set, it became 2 elements. You take the next power set, it will have 4 elements, and you take the next power set, it will have 8 elements. Right? Or is that correct or not? Or have I done something wrong? So let me just quickly write the numbers only. Maybe this, it's not just increasing power of 2 by 1. So if I take the power set of A, that is the third level. This contains 2 elements. So can I say this would contain 2 raised to the power 2, that is 4 elements. Okay. And what will happen to the next level? It will contain P of P of P of P of A. One bracket close, second bracket close, third bracket close, and fourth bracket close. The previous set, this set contains how many elements? 4 elements. So its power set will contain 2 to the power 4, that is 16 elements. Okay. So here 2 to the power 1 is 2. 2 to the power 2 is 4. Next one would be 2 to the power 4, that is 16. And therefore the answer to this question was 16. Okay. Now, if you knew the concept of power sets, you could get into this question. Okay. And once you could start this question, see the number of elements, what is happening, because it was not very lengthy and it was kind of, if you are comfortable with if you understood the concept of power set, you could have tried this one. If you are not aware of power sets, you would have left this question and gone ahead with it. Okay. But here, in my opinion, for me, this was A/B, because many students could leave. It's not something that students would not know at all. Some of them would just see that power sets is not asked so often in the exam, so they might leave it for the second round. Okay, but it's not a clear A because it's a little confusing. So that's why I'd rate it as A/B. Moving on. Many students made a mistake in this question, okay, in the actual exam. So this was something, because so many of them answered this as 1. Many of them just thought it is the power is increasing by 1. So 1, 2, 4, 8. So many answered it as 8 as well. Okay, but the correct answer is 16. Moving on. Any doubts here? Questions, anyone? Or should I go ahead? All right, moving to the next one. Question number 2. 50 distinct positive integers can be chosen such that the highest among them is 100 and the average of the largest 25 integers exceeds the average of the remaining integers by 50. then the maximum possible value of the sum of all 50 integers is how much? Okay, what I'll do here is I'll simply try to take the numbers, no highest of the. So for me, I'll try this question. If I were in the exam, I would have tried this question in the first go. Highest among them is 100, and I want 25 numbers. So I think I'll go from 76 to 100. Okay, and their average would be 88. Okay, average is 88, and these are the largest 25 numbers and exceeds the average of the remaining. But they've also asked me to take the maximum possible value of the sum. So that's why I've taken the largest numbers to be as big as possible. The next, the other 25 numbers should have an average which is 50 less. So clearly they'll have an average which is 50 less. So it will be 38. Again, if the average has to be 50 less, why not take each number to be 50 less only? So I'll take the numbers to be 26 to 50. Automatically the average would come out to be 38. And if the average is fixed, the total will also be fixed only. So I don't need to worry whether I take whether I take a 25 and remove 26 and replace it by 25 and this becomes the 51. The average would be the same, so the total would be the same. And what mattered to us was the total of all the 50 numbers. So therefore the total of all these 50 numbers would be what? 38 into 25 plus 88 into 25 and the total of it, and that should be our answer. So 38 into 25, the total value would be 38 into 25, that would be 9.5, so 950 plus 88 into 25, that would be 2200, and therefore the total answer would be 3150. Yes, I hope this question is clear. So for me, this was a clear type A question. Do you all agree? If you all agree, just put a thumbs up, or just put a thumbs up in the chat, or whatever in the wherever you have to put the reactions. Right, so again, Anshika, what part have you not understood? You have the permission to unmute, so you can quickly unmute and ask instead of me repeating the entire question. There are this would be watched by a lot many people. So yes, what part have you not understood? Okay, where did 88 come? So how do you calculate the average? From 76 to 100, the middle value is the average. 76 plus 100 is 176, divided by 2 is 88. So the average is 88 because 100 plus 176 is 176 divided by 2. Whenever you have some set of consecutive numbers, the average of the first and the last number would also be the average of the second and the second last, and that would actually be the average of the entire set of numbers. This is the property of AP. Okay, this is the property of AP, right? This is 950. If anyone is confused over here, this is 950. 38 into 25 is 950 plus 2200, and therefore the answer is 3150. Okay, Ira, is that clear? Anshika, I hope this answers your query. And again, if every number reduces by 50, the average also reduces by 50. So we get the other set, the set of other numbers which have an average of 38, and we calculate the total. So this was a clear type A question. Okay, next. A new sequence is obtained from the sequence of positive integers by deleting all the perfect squares. Then the 2022nd term of the new sequence would be what? So basically I'm writing 1. So 1 is removed, 2, 3, 4 is not counted, 5, 6, 7, 8, 9 is not to be written, 10, 11, 12, and so on. So what would be the 2022th term of this sequence if I remove all the perfect squares? Now here the trick was, how many perfect squares do you have till 2022? So I know 2025 is 45 square, and clearly I've removed 1, 2, 3, 4, 5. So if I would have written all the numbers 1, 2, 3, and so on till, or I've written that over here till 2022. Now I've started cancelling out perfect squares. So if I want to, basically I'm removing terms from between, so I'll have to continue writing ahead, right? Because I want to write 2022 terms. I removed a 1, I wrote that number. I removed 4, I write the next number in the sequence, right? 2024. I'll not write 2025 because it is a band number, it is a perfect square. So I removed a 9, I'll also have to write 2026, right? So till whatever this sequence is going, I'll be removing 45 whole square numbers, right? Because I've cancelled out till 2025. So I have to go 45 ahead of 2022, and I can't even write this. So in fact, I'll have to go 46 ahead of 2022, right? Or rather, I had to basically till 2025 there were 45 squares which have been removed. Okay, and I have to write 2022 numbers. So 1, 2, and uh, let's look at it this way. Till 20, so just for the sake of explanation, 2022 is greater than 44 square. So till here 44 perfect squares have been removed. Now I have to write 44 terms ahead of it. So first term, second term, this term is not to be counted, and I need to further write 42 terms ahead of it, right? 42 terms ahead. So if I have to write 42 terms ahead of 2025, it will be 2025 plus 42. That will take me to 2067. This would be the 2022 or 2022nd term would be 2067, because I've removed these perfect squares. So those, the count has reduced by that much. Even though I've written till 2022, the count has reduced by that much. It has actually become how much? This has become, actually, if I remove 44, this would actually become 1978th term. This is actually the 1979th term. This would be 1980th term. But I want the 2022 or 2022nd term of the sequence. So, and I can't write 2025. So beyond that, there are still 42 terms left. So if I add 42 to 2025, the first term after 2025 is this. So the 42nd term after 2025 is 2067, and that would be our answer. Okay. So the answer to this question is 2067. This was a counting based question. Explaining it can be done in multiple ways. Counting can be done in multiple ways. Every one of us generally has different ways of counting numbers. So you could have come to this answer using different ways of calculating. Okay. So that's why, you could have directly said that whatever is the number, 45 squares are going to get removed. So that's why 2022 plus 45, and that would give us the answer as 2067, because till whatever number we go, we are only eliminating 45 perfect squares, 44 till here, and one more over here as well. So that is why totally 45 perfect squares have been cancelled. So that is also another way of calculating the answer. But this was a type A question. All of us should have some way, all of us have a certain way of counting numbers. In any case, the answer would have been 2067. Okay. So moving on to question number 4. Now, if you have been an IMS student, you would have seen that we've done such multiple mod questions, and we know the function is minimum when you take the middlemost modulus. So that was the trick involved in this question. You just had to draw the number line, okay, and you had to understand that modulus actually means distance. So the critical point for this is 0. Okay, the critical point for x minus 1 is x equal to 1. So x equal to 1 and x equal to 1, I've written it 2 times because this is equivalent of having 2 mods of x minus 1. So it's like having mod of x minus 1 plus mod of x minus 1. So that's why I've written x equal to 1 twice. Okay, there are 2 roots of x equal to 1. X minus 2, so there's a root of x minus x equal to 2 as well. Okay, there's a root of x equal to 6, and there's a root of x equal to there are 2 roots of x equal to 10. So x equal to 6, and there are 2 roots of x equal to 10 and x equal to 10. And you have to find out the minimum value of f of x. If you solved a few questions of modulus, you would know, and such questions have come in the past papers as well. So we know from that experience that the minimum distance happens at the middlemost root. Okay, so this is the smallest root and this is the largest root. Okay, similarly, this is the second smallest, second largest, third smallest, third largest. Clearly, x equal to 2 is the middlemost root, and if I take x equal to 2, it should give me the minimum value of f of x. So I'll just substitute x equal to 2. If I substitute x equal to 2, this is 2 plus twice of 1, so that is 2. Okay, plus x equal to 2, so this is 0, plus x equal to 2 minus 4 is minus 2, minus, okay, I think I missed out one root. I've missed out one root, right? So I've missed out one root, I'm sorry. So there is one root of x equal to 4 as well. Okay, so now it changes a little bit, right? Now it changes slightly because now we have multiple roots involved, right? We have smallest, largest, second smallest, second largest, third smallest, third largest, and these two are the middle two roots. So when you have multiple roots, or when you don't have exact midpoint, but there are the roots are in pairs, you can take the value anywhere between the middle two roots, and that would give you the same answer. So you can take any value from x equal to 2 to 4, and your answer would be the same. So even if you substitute x equal to 2 or x equal to 3 or x equal to 4, the f of x would be the minimum only. So if I just calculate that again by putting x equal to 3, just for that understanding. So if I put x equal to 3, mod of x would be 3 plus 2 into 3 minus 1 is 2, 2 into 2, 4, plus 3 minus 2 is 1, plus 3 minus 4 is 1, mod of 1 is 1, 3 minus 6 is 3, mod of 3 is 3, plus twice of 3 minus 10 is minus 7, mod of minus 7 is 7, so twice of 7, and this should be the minimum value of f of x. 3 plus 4 7 plus 1 8 9 12 12 and 14, the answer should be 26. Okay, so that's how you generally handle modulus based questions. If you knew this trick, this was a very easy question, because we have done such questions in the past. Such questions have appeared in the past year, so you should know how to deal with minimum value of modulus based function. If you did not know this, so for some of you this could be a type B, but more importantly, I would expect my IPMAT students to know this. If you have attended the the classes and all, you would be able to handle this. Okay, moving on. The third, the 14th, and the 69th term of an arithmetic progression form three distinct and consecutive terms of a geometric progression. If the next term of the geometric progression is the nth term of a geometry of the arithmetic progression, oh my god, geometric progression is the nth term of the arithmetic progression, then n equals. So something happening in arithmetic progression and something happening in geometric progression. The third, the 14th, and the 69th term. So the third term of an arithmetic progression is, now you don't need to write these steps, okay, while you all are solving. You all have to be very quick. So third term is a plus 2r. 14th term is a plus 13r, or sorry, a plus 2d, a plus 13d, and the 69th term is a plus 68d. And these are three consecutive terms of a GP. In a GP, I know the product of the extremes is equal to the square of the middle term, right? The middle term is the geometric mean of the other two. So basically, a plus 2d is into a plus 68d is equal to a plus 13d and the whole square of it. All right, I think I can solve this. A square would cancel out. I would get some relation between a and d. Using that, will I be able to answer the question? The question is, if next term of the geometric progression So this is the first term, this is the third term, and this is the second term of the GP. So that they're telling you the fourth term of GP is the nth term of AP. So first task would be to find out the fourth term of GP, and then we have to find out which term would that be of the AP, and that would give us the answer. I've invested quite a few time, and I think this is lengthy but doable. And as per my understanding, I've already solved out of the 4 questions. I would have solved 2 to 3 questions already. So I think I have, I don't have a time crunch here. I could have, attempted this in the first go also, having analyzed the question. Okay. But having said that, if you are not comfortable with a lot of maths, ideally I would recommend that this can be kept for second round. Okay. So, but I would solve it. If you are comfortable with maths, you should definitely go ahead with this. So this would be a square plus 2ad plus 68 ad. So that will be 70 ad plus 2d into 68d. So that will be 136 d square equals a square plus 13 into 2 26 ad plus 13d, that is 169 d square. A square and a square cancels. There's a d in each term, so I can cancel out the d because common difference won't be a common difference. If common difference becomes 0, then there won't be 3 distinct terms. It'll all be the same term, which we don't want. So d cannot be 0. So d will cancel out from each term. So now what we are left with is 70a plus 136d is equal to 26a plus 169d. Rearranging the terms, 26a comes here, you'll have 44a equals 169 minus 136, that is 33d, and therefore a upon d, the ratio is 3 upon 4. See, as long as the question is only about the nth term, this ratio alone is sufficient. We'll simply say, let us take a equal to 3 and d equal to 4 and get our answer for this question. So if I take a equal to 3 and d equal to 4, first of all, the first term of the GP, is, my GP is what? First term of the GP is a plus 2d, that is a plus 3 plus 4, 8, that is 11. The second term would be a plus 13d. 13 into 4 is 52 plus 3 is 55. Clearly, my GP is getting multiplied by 5. I wanted the fourth term of the GP to be equal to nth term of AP. So what will be the fourth term? The next term would be this into 5, or that can also be calculated from here, a plus 68d. So 55 into 5 is 275. This is the third term, and the fourth term would further be into 5. So this would be, or rather, you could have calculated it as 11 into 5 into 5 into 5, 125. 11 into 125 is 1250 plus 125, 1375. This is equal to the nth term of AP. What is the AP? In the AP, my first term is 3 and my nth and my common difference is 4. So this is equal to 3 plus n minus 1 into 4. Solve this and you should have your answer. So 3 comes on this side, 1372 is equal to n minus 1 times of 4. 4 goes in 13, it goes 3 times, remainder is 1. In 17, it goes 4 times, remainder is 1. And 12, it goes 3 times. N minus 1 is 343. Therefore, n would come out to be 344. And that should be our answer. So n would be 344. Again, this was a type A/B. Depending on your comfort and what state of mind you are in, if you are able to think of this in the first go, definitely you should attempt it. Otherwise, you could have done this in the second round also. This would hardly take 2 minutes. Okay, it's lengthy, it has a long solve, but you should observe one thing. How many concepts are involved? See, there's an AP involved, there's a GP involved. Then they've given you the relation. You had to solve it. You had to first find out the relation between A and D. Then you had to find out what would be the fourth term of GP and equate it to nth term of AP, and then you had to get the value of N. So that is how many, 4-5 connections involved in the question. So that's why this could sometimes, not click in the first round. So if it does not, nothing to worry. You could still have attempted it later. Okay. You'll definitely find
Sir,
time to come back to such questions. Okay. Yeah. Yes, Ira.
sir, in this question, I have done it a little differently.
Huh?
So I have arranged like 3, 14th and 69. So 3 into 5 minus 1 is 14. 14 into 5 minus 1 is 69. And so 69 into 5 minus 1 is 344. So can we, is it right to do in this manner?
No. There would be some maths involved over here, but again, you're not going to get this question. That these terms of an AP are three consecutive terms of a GP, and if you find a LR type sequential pattern here and get to the answer. So yes, maybe whatever calculation you're doing, say if you're getting 344, the specific question type that we have over here, it might be fitting in over there. But do you have a logical explanation why that should hold true?
So I just sort of try to made in sequence. So
But it's not a sequence ka question, na, Ira. It is a
yes, sir.
AP GP ka question. So yeah, maybe there is some maths. Maybe we'll calculate, and from the back, if we do some calculations, we'll realize, okay, because these are in GP, it has to hold true this way. What you're saying, but it's not a method that we can kind of take as a generic method that we'll use, or something which we'll do when we get such questions. So
Okay,
yeah,
sir.
matlab,
Thank you.
it is holding true over here, good, but not something which we will be able to use every single time. Okay, so moving on. Why is the question number not appearing? For some reason, question number 4, question number 5. Okay, now we are moving on to question number 6. The numbers minus 16, 2x plus 3, 2 raised to x plus 3 minus 2 raised to the power 2x minus 1 minus 16, and 2 raised to the power 2x minus 1 plus 16 are in arithmetic progression. Then x equals. I'll keep this as a type B. For me, this is appearing to be a little calculative because the numbers are in powers of 2. So I'll come back to this later. Okay. If A is this, then what is the absolute value of the determinant A plus A cube plus A to the power 6 plus A to the power 9? So I'll have to calculate A. Say first of all, I'll calculate A square as A into A. Then for A cube, I'll have to do A square into A. Then for A to the power 6, I'll have to do A cube into A cube. And for A to the power 9, I'll have to do A to the power 6 into A to the power 3. All right, what I'll do is, and I need to calculate the determinant of it. Okay. Because sorry, I don't need to calculate the determinant of each one of these. The question is to calculate the determinant of A plus A cube plus A to the power 6 plus A to the power 9 and the determinant of this. It seems to be a type B for me for now. I'll come back to this later. However, the elements of the matrix are kind of straightforward: 1 0 0 0 0 1. Let me just quickly try this one first. Let me just try A square. If I'm able to do this properly. 1 0 0 0 0 1 0 1 0 into 1 0 0 0 0 1 0 1 0. So again, I've seen this question, I know, so that's why I'm telling you, how you would kind of think in the exam. So it's not as if I'm seeing this question today for the first time. So if I do the multiplication, again, if I have to end up doing so many multiplications, it's going to be very difficult. So let's quickly check. This is going to be 1 into 1, this row into this column. There's only 1 into 1 which will happen. Next, this element would be this row into this second column. 1 into 0, 0 into 0, 0 into 1, it will end up being a 0 only. Next element would be first row, third column. Again, no 1 into 1 will you'll find, so it will again be 0. Okay. What about the second row elements? Second row into first column. There's no 1 into 1 happening. 0 into 1, 0 into 0, and 1 into 0. So there will be, it will be a 0 only. Second row into second column. This last and this last will match, right? Because first into first, second into second, and third into third, 1 into 1. So this will give you a 1. And second row, third column of this one would be, again, there's no 1 and 1 matching, so it will be a 0. Here again, third row, first column, first element and second elements are 1, no ones will match. First row, third row and second column, again the ones will not match. Third row, third column, 1 and 1 both are in the second place, so they will match, and therefore you get a 1 over here, and that is nothing but an identity matrix. As soon as I see that it is an identity matrix, I realize now the calculation could become a little easier, because identity matrix is any matrix into an identity matrix is that matrix itself. So if A square is an identity matrix, A square into A will be A only, and A cube into A cube is the same as A into A, which is nothing but A square, which is an identity matrix. And A to the power 9 would be A to the power 6 is identity matrix into A matrix is the A matrix. So ultimately the question has reduced to A plus A cube is also A plus A to the power 9 is also A. So 3 times of A plus identity matrix and calculating the determinant of it. So wherever you have a 1 in the wherever you have a 1 in the A matrix, it will get it will become a 3, and identity matrix will get added to it. So this 1 plus 1 plus 1 in these positions will get added. So ultimately this will be the determinant of 3 over here plus 1 from the identity matrix, so that will be a 4. There's no 1 in this place for both the matrices, so 0 and 0 only. 0. Identity matrix has a 1 over here, and A matrix has 1 over here, but it will become a 3. 0 for both of them. This one is 1 for A matrix, it will get multiplied by 3, so that will become a 3, and identity matrix 1 over here. So ultimately I have to calculate the determinant of this matrix, and hence the determinant would be what? The determinant would be 4 into 1 into 1 minus 3 into 3. 1 minus 9, that would be minus 32. But the question clearly stated absolute value of, so minus 32 mod of minus 30. So we are looking for the mod of modulus of this. So modulus of this, and hence the modulus of this would be nothing but 32, and that would be our answer. Okay. Not, I can clearly see that most of you would have this fear of matrices and determinants question. So this may be a type A or a type B. Okay. But if you look at the actual, when you look at the paper, or when you look at the question after the exam, it is a very easy question. When you are in the exam, to be able to judge this in the limited time that you have in the exam is the challenge. Okay, that itself is the biggest challenge. Okay, so let's move on. Any questions here? Anyone? So let's go ahead. Okay, so this was question 6 for today. Question 7. When Geeta increases her speed from 12 to 20, She takes 1 hour less than usual time to cover the distance between her home and her office. The distance between her home and her office is dash kilometers. What is this? Is this a type A, type B, type C, guys? I want your take on this question type. Should I solve it or not? If you face this question in the exam, I think this is the starter question, that you face, that you come across when you have these proportion based questions, proportionality in time, speed, distance. And therefore, this is a must solve. This is a sitter question. Okay. So speed in the first case versus the speed in the second case was 12 is to 12 is to 20, right? Speed in the first case and speed in the second case, or generally we in my class I generally teach this way, that there's a distance from A to B. Speed 1 was 12, speed 2 was 20. Let the time taken over here be T1. So what should be the time taken in the second case? As per the question, she takes 1 hour less, so T1 minus 1. Here the time will come in hours. Okay. But as per the relation of inverse proportion, if S1 upon S2 is 12 is to 20, that is 3 is to 5, S1 upon S2 is 3 is to 5. Therefore, first time upon second time would be 5 is to 3. So therefore, T1 upon T1 minus 1 would be 5 upon 3. Solve this and you will get the time. So 3T1, 5T1, 3T1, 5T1 minus 5. You solve this, you'll get 2T1 is 5. Therefore, T1 is 2.5 hours. Okay. Time taken in this case is 2.5 hours and the speed was 12 kilometers per hour. Therefore, the distance would be 12 into 2.5, that is 30 kilometers. This is a sitter question. This question must and should be attempted. You can't and you must not miss out on this question. Okay. So this was a clear type A question. This was a clear type A question. If I had to go to the previous question, I would rate this as, again, not a straight B. This would be A/B. But this one was a clear, the seventh question was a clear type A question. You can't miss out on this. This one, guys, if you have studied binomial theorem in class, I think you all should be able to tell me. I'm not telling you asking you to give me the answer, but you can tell me whether this is a type A, type B, or a type C. Is this a very lengthy question? Is this a very easy question? What is it? What should be done in this question? As soon as you're asked the sum of all the of the coefficients of all terms in a certain expansion, the in any binomial expansion, if you all recall, any expansion would have some numeric part into x to the power something, plus some numeric part into x to the power 3, plus some numeric part into x to the power 2, and there'll be a lot of terms. If I just want the numeric part, or if I just want A, B, C, if I just want what is A plus B plus C, and I don't want this x part at all, how do I get rid of this x? What should I do with this x? I just want to get rid of it. I just want to keep the numeric part and not want that x wala part, the x coefficient part, or the variable part. How do I deal with that? Anyone? What's the trick here? So those who have put it that this is a type A question, what's the trick here? If I just want
Sir, actually, I did this question, but I didn't do it like this. Sir, so if you,
okay. If there's a different method, we'll come to it. Okay.
but I think we can take common over here, maybe.
Okay. The trick here was, I just want to keep the A, the B, and the C. I don't want the X part at all. So why not just put X equal to 1? X will vanish, A will remain. X will vanish, A will remain. X will vanish, C will remain. D into X, there'll be some numeric part. Why am I saying this? Because the binomial coefficients, see here inside there are numbers. When you have A plus B, the whole to the power 4, and I ask you sum of coefficients, you could have directly told me that the answer would be 2 to the power 4. Okay, because the variables inside did not have any numeric coefficients, but here X has the coefficient 5 and 9 also has some numeric value. So coefficients would have all the numbers that are there, just not the variable part, right? So that's why this cannot be applied over there, 2 to the power 4, because there'll be some powers of 5 also involved, there'll be some powers of 9 also involved. So therefore 2 to the power 4 is not the correct answer to this question, if you all are thinking about that. But if you look at this expansion, 5x minus 9 to the power 4, it will have some term which will have x to the power 4. Let us say with the 5s and with every other thing, whatever numeric part is there, that is a into x to the power 4 plus b into x to the power 3, and so on, dx plus e. We are only looking to find the value of a, b, c, d and e ka total. So if we do not want x, the trick that I've told you is I put x equal to 1. If I put x equal to 1, what does the RHS become? RHS would simply become a plus b plus c plus d plus e. Isn't this what we are looking for? Isn't this what we are looking for? Am I right? But if I'm putting x equal to 1 on in the RHS, I should do that on the LHS also. So if I put x equal to 1 in the LHS, 5 minus 9 becomes minus 4, and minus 4 raised to the power 4 will simply be your answer. So this is the trick for such questions. Remember note this down. This kind of a question has been covered in the IPM special sessions, which in the class which you have binomial theorem, the sum of all coefficients of some irregular binomial expansion where you have numbers also within the within in the binomial. In that case, you simply have to put variables equal to 1. Automatically, you'll get the sum of all the coefficients. So this is a trick, and only if you knew this trick, this was a type A question. Otherwise, this would turn out to be a slightly lengthy question. But now that you know this trick, it should be a type A question. Okay. So answer to this question, what we wanted was a plus b plus c plus d plus e, and that is minus 4 to the power 4, which is the same as 4 raised to the power 4. 4 raised to the power 4 I know is 64 into 4, that is 256, and hence the answer to this question was 256. How many of you knew this from before, or how many of you learned this today? Let me put it this way. If you learned a new trick today, just raise your hand or just put that in the chat. I'll be happy to know how many of you are kind of seeing this for the first time. Okay, I hope this was a very helpful trick. It's such an easy trick, but many of us have missed out, or would have missed out on this. But I hope this question, solving this question has at least taught you one new thing today. Okay, chalo next. All right, let's go ahead. Aruna purchases a certain number of apples for INR 20 each and certain number of mangoes for INR 25 each. She sells all the apples at 10% profit and all the mangoes at 20% loss. Overall, she makes neither profit nor loss. If she sells all the apples at 20% loss and all the mangoes at 10% profit, overall she makes a loss of rupees 150. Then the number of apples purchased by Aruna is. Guys, such questions are covered in profit loss, preparatory concept classes. So first thing was apples and mangoes. Cost is 20. Mango, the cost is 25. If she sells all the mangoes at 10% profit, the profit would be 2 per piece, and mangoes, the loss is 20% of 25, that is 5 per piece. Okay, and she makes neither profit nor loss. Therefore, the number of pieces would be what? Can I say if the number of pieces here is X and the number of pieces here is Y, the number of pieces 2 per piece into X, the amount of loss and the amount of profit would be the same. Here it is a loss of 5 rupees, so minus 5. So can I say 2X is equal to 5Y, and from here you'll get X upon Y is equal to 5:2. So you can take X is equal to some 5K and Y is equal to some 2K. So the number of pieces of apples and mangoes are 5K and 2K. But now they've given you a certain, say, a different situation. Instead, if she tells all the apples are 20% loss, so now instead of this, if you had a loss of 20%, that is minus 4 per piece, and on the mangoes 10% profit, that is plus 2.5 per piece, then overall she makes a loss of rupees 150. Okay, so what is the loss per piece? 4 per piece. For how many pieces? 5K pieces. So can I say the net loss is minus, see, this is already a loss, huh? So let's not deal in terms of loss. We'll say what is the amount of profit? The amount of profit is minus 4 per piece for 5K pieces. So net profit is minus 4 into 5, that is minus 20K. What is the profit here? 2.5 into 2K, that is, can I say, plus 5K. And numerically the net profit was a loss of 150. So can I say the profit was minus 150? You solve this, you get the value of K, and hence you'll get the value of apples also. This is a type A. This can't, you can't get IPMAT. This is IPMAT exam, and if IPMAT Indore, and if you want if you want some marks, you can't pray for easier questions than such these questions. These are like concept questions, so you should be able to handle such questions very easily. So minus 15K is equal to minus 150. Therefore, K is equal to 10. If K is equal to 10, apples were 5K, that is 50, and hence your answer should be 50. Right? All the students who are attending this on Zoom, can you all just let me know if this answer, if you are convinced with this method, or and do you agree with me that this is a type A? So just put a, if you agree that it is a type A, just put a in the chat. If you feel that no, it is a type B question, it's very lengthy, I couldn't have thought of it, put a type B. What is your take on this? A, right? Okay, wonderful. So another straight A. Okay, you all know the cutoff for this paper. We'll discuss that at the end. Okay. Mr. and Mrs. Sharma, Mrs. and Mr. Sharma, and Mrs. and Mr. Ahuja, along with 4 other persons, are to be seated at a round table. So, Mr. Sharma, Mrs. Sharma, Mr. Ahuja, Mrs. Ahuja, and you have P1, P2, P3, P4 around a round table. Mrs. and Mr. Sharma are to be seated next to each other only. So they sit together only. Okay. And Mr. and Mrs. Ahuja don't want to sit together. Then the total number of seating arrangements would be how much? Okay. So Mrs. and Mr. Ahuja don't want to sit next to each other. But Mr. and Mrs. Sharma would definitely want to sit next to each other. And this is a case of circular arrangement. Okay. So how do we deal with this? First of all, whenever we are dealing with questions based on people sitting together, we treat them as one entity and then we look at internal arrangements. Okay. P and C. Then when we have to separate people, what we try to do is we first make the others sit and then put the people to be separated in the gaps. Okay. And with that, there is also circular arrangement involved. If I'm in the exam, I might get a little overwhelmed with this. I'll put this as a type B, maybe. Okay. and I'll come back to this at the end. Okay. So normally I would have put this as a type B and I would have come back to the, come back to it later. However, now I'll quickly solve it. I'll show you how you would have done it. So if I consider, if I have to separate these two people, okay, separate Mr. and Mrs. Ahuja, they can't sit together. So what we'll do is we'll first make the others sit and put one chair between them only, and that would define, the positions of Mr. and Mrs. Ahuja. So how many external entities do we have? 1, 2, 3, 4, 5. We want 5 entities to be seated around a circle. We've done circular arrangements. Can I say these 5 entities? 1, 2, 3, 4, 5 around the circle. 5 around the circle can be done in how many ways? 5 around the circle, five things around the circle can be done in how many ways? The arrangements n minus 1 factorial. So can I say they can be arranged in 4 factorial ways? Okay. But after arranging this 1, 2, 3, 4 and 5 things around a circle, I realized that Mr. and Mrs. Sharma can keep switching places within themselves. It could be Mr. Sharma on the left and Mrs. Sharma on the right, or it could be the other way around. So I'll have to consider for internal arrangements of Mr. and Mrs. Sharma. Right? So they can arrange internally in how many ways? Whenever you make any arrangement, they can internally arrange themselves in 2 factorial ways or 2 factorial or 2 ways, which is nothing but. Okay. Plus, once I've made Mr. and Mrs. Sharma sit, Mr. and Mrs. Sharma, okay, and say there is a P1 here, there's P2 here, any one arrangement, P3 here, and P4 here. Once I've made them sit, I also have to make Mr. and Mrs. Ahuja sit, right? So Mr. and Mrs. Ahuja can be offered chairs in how many ways? So for them, what you'll do is you'll place chairs here na, in the gaps so that Mr. and Mrs. Ahuja are by automatically separated. They can't sit together. So how many chairs you have? 1, 2, 3, 4, 5. But please note this is no longer a circular arrangement because the others are already sitting. So each of these place is a differentiable chair or a differentiable position. So therefore you don't do a n minus 1 factorial over here. So 5 chairs and 2 places to be filled for Mr. and Mrs. Ahuja. That can be done in how many ways? I have 1, 2, 3, 4, 5 chairs and only Mr. and Mrs. Ahuja have to be seated here. Why they have to be seated here? Because they didn't want to sit together. So what we did is we made others sit and in the gaps we put in the chairs, right? So 5 chairs, 2 people, number of arrangements are 5p2, which is nothing but 5 into 4, right? Mr. Ahuja can choose any of the 5 chairs. Mrs. Ahuja will only get the one of the 4 remaining chairs. You could have looked at it that way. The last part of this question was I have to do this first thing and I have to do the second thing and I have to do the third thing. Whenever you have an and involved, the number of ways get multiplied and therefore your final answer would simply be 4 factorial into 2 factorial into 5 into 4, and that would be 24 into 2 into 5 into 4 is 20. So 40 into 24, the answer would be 960. Hence, this is 960. Okay. What is your rating of this question? I would generally keep it as a type. If see, I know this question. I know this concept very confidently, so I would have kind of done it. But my understanding is that students would find it to be type B. But what was your perception when you looked at the question? Were you able to interpret the same method? So type A or type B for you? A would mean that you solve it in the first go. B would mean that you would come across it and come across and solve it in the second round. So Sneha says type A. What about others? Others didn't solve only a word. Manas agrees with me. Okay, type B. All right. So let's quickly go ahead with the solving to the next question. Seventh, okay, eighth. This is Q8, Q9, and Q10. This one would be Q11. So the 11th question. Oh, I don't know what's your take? Type A, type B, type C. Type, okay, Sneha says C, Manas B and C, Yug C, type C, B, C. Okay. All right. This was a really difficult looking question. Okay. So yes, you are right. Ideally, such questions are not to be solved. You're not here to win a maths Olympiad or something. You have to be smart to solve maximum number of questions. So there's no extra points for solving difficult questions. So if this question looks difficult, leave it. If you get the time at the end, come back to it later. Okay. But now I'll quickly discuss how we could have solved this. So sine alpha plus sine beta is equal to root 2 by root 3. Cos alpha plus cos beta is 1 by root 3. Then what will be the value of this? Now guys, understand one thing. The question, chalo, let us, if you've not looked at the solution, or done any solve, looked at what needs to be done here elsewhere or something, you can tell me, or you can, if you genuinely tried it on your own, what did you think about this question? Okay, because I know a solution would be available everywhere, across the internet, so everyone knows how to search on the internet. But if you've not searched on the internet, and if you tried solving this on your own, what would be your take? What should be the thought process? How do I come across to the next step? So generally the thought process here should be to be able to deal with sine alpha, sine beta, alpha, cos beta. I know only one identity, that is sine square theta plus cos square theta is 1. If I were to use that over here, the first step would involve taking square. If I take square, this would be sine square alpha cos sine square beta and 2 sine alpha sine beta. So sine square alpha plus sine square beta plus 2 sine alpha sine beta. Okay. Similarly, if I take the whole square here, okay, sorry, I need to write the RHS also. So the RHS would become 2 by 3. Similarly, cos square alpha plus cos square beta plus 2 cos alpha cos beta, and that would be 1 by 3. Now I can see pairs. Sine square alpha plus cos square alpha 1. Sine square beta plus cos square beta is 1. And 2 sine alpha sine beta cos alpha cos beta. What happens to this part? This is the critical point here. What do you get if I add 2 sine alpha sine beta plus cos alpha cos beta? So I can take 2 common. Sine alpha sine beta plus cos alpha cos beta. Have you seen this anywhere? Is this something which is seen earlier? If you crack this here, you have your answer. No, this is not sine A plus B. This is cos of A minus B, right? Cos of A minus B. If you remember, this would be cos A cos B minus, sorry, plus, the sign is opposite. If you have minus here, it is a plus here. Sin A, sin B, right? If you recall this, you would be able to, get to the answer of this. Okay. So this was the important identity to be used over here. So to sin alpha sin beta minus cos alpha plus cos alpha cos beta is actually cos of alpha minus beta. This was the trick over here. The order is not important. Should it be alpha minus beta or should it be beta minus alpha? Doesn't matter, because cos of A is equal to cos of minus A. So if the order is ulta, doesn't matter. Okay. So therefore it wasn't important. What was important here was you'll get cos of alpha minus beta, and something related to that was asked in the question. Okay. So if I take that into account, I could quickly go ahead. 1 plus 1 plus 2 common, and this became cos of alpha minus beta, and that is equal to 2 by 3 plus 1 by 3. Can I say that is a 1? One of the ones get cancelled. You get cos of alpha minus beta is equal to 1 goes on the other side, minus 1 by 2. Okay. Now I have cos of alpha minus beta, but I wanted cos of alpha minus beta by 2. Okay. The smartest way to deal with this question, see, this is a multiple, this is not an MC option based question where you have multiple cases possible. When this question comes in your theta question or short answer section, only single answer is possible. Okay. So can you think of any alpha minus beta or any value for alpha minus beta for which cos of alpha minus beta is minus 1 by 2? Can anyone tell me what value for alpha minus beta can I take for which this will satisfy? Anyone? So when is cos 1 by 2? Cos is 1 by 2 at cos of 60 degrees. Cos of 60 degrees is 1 by 2, but this is minus 1 by 2. So this should be in the second quadrant. So think of an angle in the second quadrant. So 180 minus 60, I could have taken this as cos of 120, right? So what I'll do is I'll just think of a number which satisfies this condition. So 120 degrees satisfies this condition. So if alpha minus beta is 120 degrees, cos of alpha minus beta by 2 would be 120 by 2, that is cos of 60 degrees, and that is also 1 by 2. So that is what was required here. That okay, you just had to find out cos of alpha minus beta by 2, that is 1 by 2. If you put that over here, 1 by 2, 20 into 1 by 2 would be 10. 10 square is 100. The answer to this question was 100. But clearly this question was not a type A question in my opinion. If it clicks to you that you had to take the square in the first go itself and then go ahead, then you might perhaps solve it. But again, this would be a slightly lengthier question, because you had to solve cos of alpha minus beta, and then you had to again basically interpret or assume this value. If you knew the identities and you want to solve and come to here, it's again a lengthy affair. So that's why this is a type B or a type C question. Okay, right? Should I go ahead next, or any queries here? All right, moving on. One second. Huh? Yeah. The number of triangles that can be formed by choosing points from 7 points on a line and 5 points on another parallel line is, guys, your take appears to be too lengthy, or what is it? Type A, B, C. Is it too lengthy, difficult, not difficult? Priyam says type A, Sneha says type B. Now we have a tie. What about the others? Type A. This is a very simple question. You have seen this. These are taught in the initial few questions of geometry based permutation combination. So there are 7 points along one line. and there are 4 points, or sorry, 5 points another along another parallel line, and you have to form triangles. So we generally know we have to choose points from here. I think we should be able to handle that. So number of triangles that can be formed by choosing 7 points on one line and 5 points on another parallel line. You could either choose 2 from here and 1 from here, or it could be 1 from here and 2 from here. These are the only possibilities, right? So you can just calculate this and get to the answer. 1 point from here would be 7, and 2 points from here, that will be 5c2. So 7c1, that is 7 into 5c2, that is 5 into 4 by 2, or means plus sign, and the calculation would for this one would be 7c2, that is 7 into 6 by 2, and means multiplication, and out of 5 any one point, so that is 5c1, which is nothing but 5. So this calculation would be what? 10 into 7, 70, or that is plus, this would be 21, 7 into 3, 21 into 5. This calculation would come out to be 105, and hence your answer would be 70 plus 105, that is 175. Not at all a lengthy calculation. Have I done the calculation correct, guys? Those who have answered this as type A, Manas, Priyam, did you all try this question and get the same answer if you're saying that it is a type A question? Let me know in the chat. Okay, perfect, very good. So this was question number 12, another type A question. Okay. What next? The area enclosed by this is less than 6 is what square units? Guys, so many such questions that we've solved already in IPM special sessions and the concept classes of IMS. When you have, so less than 6, right? So first of all, what we'll do is we'll solve for 2 mod x plus 3 mod y is equal to 6. If you remember such questions, we've taken plus, 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 minus, minus, plus, minus, minus, and you'll get it in quadrants. So how would this look in quadrant 1? In quadrant 1, basically, you'll open it up as 2, because x is also positive and y is also positive. So in Q1, the equation, the line that you'll have is 2x plus 3y equal to 6. When your x and y are in quadrant 1, x and y both are positive. So the mod will become, see, the only condition with mod is that if mod x is positive, if x is positive, mod opens up as it is. But if x is negative, mod introduces another minus sign, and minus into minus makes it a positive. So in first quadrant, both x and y are positive, and because both x and y are positive, mod will simply open up as x and y itself. So in quadrant 1, 2x plus 3y is 6. You can plot this line. If I put x equal to 0, y comes out to be 2. But if I put y equal to 0, x comes out to be 3. So this is the line that we have over here. You'll realize if you put second quadrant, x is negative and y is positive. So x will open up with a minus sign. So in second quadrant, 2 into minus x, so minus 2x plus y opens up as it is because y is positive in the second quadrant. So plus 3y is equal to 6. Put x equal to 0, y comes out to be the same, but put y equal to 0, x comes out to be minus 3. At this point, you should already realize that it is going to be symmetric, and you've also done questions like this already. So you would know that this will form a shape like a rhombus or a diamond. And what is the area? This is a rhombus. So therefore, the area would be half into d1 into d2, or you can simply calculate the area of this triangle and into 4. Area of this triangle is half into 2 into 3. The area of the first triangle is half into 2 into 3, that is 3. So 3, 3, and 3. The total area would be 12 square units, and therefore the answer is 12. Now you would say there is no equal to sign, there is an inequality here. But if you look at it carefully, area enclosed by this inequality is nothing but, the area enclosed means, the area for 2x plus 3y less than or equal to 6 would be the area which is beneath this line. For the second part, it is this region. For the third part, it is this region. And for the fourth part, it is this region. So therefore, this itself comes out to be the area enclosed. Okay. For those who have doubt, how do you put, how do you check whether this, whether which region would be the greater than one or the less than one? So just a quick hint. Let me just draw the diagram again. Okay, this was the line x 2x plus 3y equal to 6. We had to find out which part is less than and which part is greater than. So we know this point origin is on this side. Let me put x equal to 0 and y equal to 0. If I put x equal to 0 and y equal to 0, 0 plus 0 is less than 6, right? So therefore this is on the less than side. Okay. Similarly, for the second line, this line was minus 2x plus 3y equal to 6. I want to check origin is on the less than side or the greater than side. So let me just put origin over here. Minus 2 into 0 is 0 plus 0. 0 is less than 6. So therefore this is the less than side, right? And likewise, you can check for the equations that you get for the third and the fourth quadrant as well. Okay. Substitute the value of any coordinate which is known and check for that coordinate, is it coming out to be less than or greater than? So for that side, you'll get the inequality as well of the on the graph. Okay. So this was, again, in my opinion, all students should take this as a type A question, because you have studied such questions in your theory part. Okay. So this is a type A question for me. Log of y to the base x square plus log of x to the base y square is 1. And y is equal to x square minus 30. Then y value of x square plus y square is. Okay, in my first take, I would generally put this as type B, or maybe B/C also, but doesn't appear to be a question that I'd want to solve immediately. Okay, but yeah, let's have a look at it. Okay, what we've been given here is y is equal to x square minus 30, and okay, so what we'll do is, first of all, get the x square out of the base. Okay, so if I have power in the base, this will become 1 by 2 log of y to the base x plus 1 by 2 log of x to the base y equal to 1. If I take the 1 by 2 common and take it on the other side, I have log of y to the base x plus log of x to the base y is equal to 2 from the denominator goes to the other side. Okay, so 2. Now again, how do I deal with this? So I should know log of a to the base b is equal to 1 upon log of b to the base a. Okay, so that is one more important thing that we could have done here, right? So if I put that over here, I would have got log of y to the base x plus 1 upon log of x to the y to the base x is equal to 2. Now I could have solved this as a quadratic. Okay, but guys, do you see this as a plus 1 upon a equal to 2? And have you studied something about any number plus its reciprocal, any property related to that? Anyone? What can be said about any number and its and its addition with the reciprocal? So a plus 1 by a, what is the property that we can always say about it? Hriday says it is greater than or equal to 2. Absolutely right. Any number plus its reciprocal is always greater than or equal to 2, and equal to 2 happens only if equal to 2 happens, and equal to 2 happens only when a is equal to 1, right? If you were aware of this, after this step, you could have directly said log of y to the base x plus 1 upon log of y to the base x is equal to 2. Clearly, number plus its reciprocal adds up to 2. This would be possible only when this number is equal to 1. You can put in a lot of values and check. So I could have directly said from here log of y to the base x is 1. Therefore, x is equal to y. Okay. but we've also been given y is equal to x square minus 30. So x is equal to, if I put x square minus 30, x square minus 30, from here I would have simply solved and got the value of kind of the x and the y. So from here you would have got x square minus x minus 30 is equal to 0. And if you substitute again, you solve this quadratic, you'll get x is either equal to the split would be minus 6 and plus 5. Therefore the change of sign, x would be equal to 6 or minus 5. Okay, x is equal to 6 or minus 5. Now which value should we take? Or I think, should I get multiple answers? X is either equal to 6 or equal to minus 5, and y is equal to x square minus 30. So 36 minus 30, y would come out to be 6, or y would come out to be 25 minus 30, that is minus 5. Is there any issue with x equal to 6 or x equal to 5 minus 5? Because otherwise I'll have multiple answers possible here. So any restriction here? Yes, Hriday, absolutely right. Log contains y within it and x within it. And for log, the values inside the log cannot be negative. So x equal to minus 5 and y equal to minus 5 are eliminated. And therefore, x is equal to 6 and y is equal to 6. So therefore, x square plus y square, it would be 36 plus 36. The answer was 72. Okay. How many properties were used over here? First property, the property of the base of log, property number 1. Then the second property that we used was, the property that log of a upon b, or this is the second property that we used. Log of a by b is equal to 1 upon log of b to the base a. The third property that we used was this one. If I know a plus 1 by a is equal to 2, that happens only if a is equal to 1. Right? This implies that a is equal to 1. Third property, and after that the fourth property was the input of a log should be positive. So this is the fourth property that we used, or rather the elimination of the negative roots, and then we got to the answer. This question, if you look at it after the exam again, it would appear like you could have solved this. But when such a question comes in the exam, to be able to apply all these properties in a single question in that exam environment creates the challenge. So therefore I put this as a type B question. But keep in mind, now you've seen these questions. Remember, even the type B questions of this exam are something which you could have solved. So therefore, when you go in your actual exam and you come across questions which appear to be very lengthy or tricky, don't worry, just keep them aside for some time. Automatically your brain in the background would start working on those questions, and when you come to that question in the second round, probably you would be able to solve it a little faster. Okay, so therefore this is something which is important. Whenever a question looks difficult, hang on, keep it aside for some time, go to the next question, and when you come back to it, maybe you might be able to tackle that question a little better. So this was the second last question, question number 14, a type B question. Moving on to the last question. Okay, I think I've done a wrong count then. If this is 15, oops, 14, I think I missed out a question count somewhere. 13, 12, 11, 10, 9, 8, 7, 6. So in fact, I have covered all the questions of this sheet, and you can see that it wasn't such a difficult paper. What was the cutoff of this section? What was the cutoff of the actual paper? The cutoff for this section was it wasn't 24. If I'm not wrong, it is 20. For MCQ it was 43, but for short answer it was 20. I think it is manageable, but there's a word of caution here. Even though the questions were so doable, manageable, why is the cutoff so low? That is because in the short answers you don't have options to verify. So many of the students would have put 8 as the answer here, and because you don't have options to check whether what you're thinking is right or not, sometimes your answer and the actual answer would be very vague also. Okay, so factoring that in this situation, you will see that 20 or a 24, in my opinion 24 was a justifiable, could also have been the cutoff for this section. But now let us see what should have been a good score. This I am not considering that you would have done it. Okay, chalo. I will assume that from a student point of view, that you are not able to comprehend this in the exam, you won't do it. Not a must do question, but this is a must do question first. Second question that had to be done. Okay, I'll leave this aside. Chalo, you couldn't handle this one. 2 questions you did. If you couldn't handle that previous one, this is a very straightforward one. You just had to solve a lengthy situation. Okay, there was no trick involved here. So this is a question which was doable. 3. I'll leave this one. Okay, I haven't solved this one question yet, so we'll have to solve this one. I'll come back to it. The 4th question here, this one again lengthy, maybe I'll not count this yet. This one was a doable, so 4th question that should have been done. Another question that could have been done easily. This one is a must do question, so 6th question that you should have done. Another question that should have been done, so I'll just keep this as, I'll not count this because, okay, 6 questions, because okay, maybe you might be able to handle or not handle this in the exam. I'll leave this one aside. This one was a must do, so this is the 7th question that should have been done. I think this one was another question that should have been done. Okay, so out of the 15 questions, even if I'm being very lenient, I'm not expecting you to do big things or solve tricky questions. There were 8 easily doable questions which were based on whatever concepts you have actually already done. Okay, so that is why if you ask me a good score can't be keeping in mind that you don't do difficult questions, right? Good score also involves that you have done slightly a couple of tricky questions maybe. Okay, so I'll not count a lot. I would say a good score in this section, would be, maybe you would have attempted 10 or 11 questions, because you would attempt more but some questions would go wrong. So I'll assume that you at least get 7 or 8 questions correct. So therefore a good score in my opinion for this section was 32 or more. So out of the 8 easy questions, it is possible that you might answer a few questions, your answer might miss the actual answer by a little margin, so that can go off. But yeah, you could have answered a couple of difficult questions or a slightly tricky ones, and you could have covered it up that way. So out of the 10 or 11 questions that you would attempt, you could have you should get around 8 correct. Okay, now coming to the last question for this evening, the numbers minus 16, 2x plus this minus 2x plus 2 raised to x plus 3 minus 2 raised to 2x minus 1 minus 16, and 2 raised to x minus or 2 raised to 2x minus 1 plus 16 are in AP. Whenever 3 numbers are in AP, first number plus the last number is equal to twice of the middle number. The middle number is the average of the other two. So let us write it that way only. 2 raised to the power x plus 3 minus 2 raised to the power 2x minus 1 minus 16 is equal to this plus this divided by 2. Can I say minus 16 plus 16 will cancel out? 2 raised to the power 2x minus 1 divided by 2. Okay, this question is you would have come across such questions in quadratic equations. Such questions need to be solved as a quadratic equation. So 2 raised to the power x plus 3, can I say this is nothing but 8 into 2 raised to the power x minus 2 raised to so minus 1, so basically you'll have a 2 in the denominator and 2 raised to the power 2x minus 16 equals minus 1 in the power. So can I say 2 raised to the power 1 in the denominator would get multiplied. So that is 2 raised to the power 2x upon 2 into 2, that is 4. And if I get this over here, finally you have 2 raised to the power. So I'll multiply throughout by 4. Let's make it easier. Multiply throughout by 4. So that is 32 into 2 to the power x minus. If I multiply by 4, this will get multiplied by 2. So 2 into 2 raised to the power 2x. 16 into 4 is 64 equals 2 raised to the power 2x. If I get everything on the RHS, you'll get 2 raised to the power 2x plus twice of it. So can I say 3 times of 2 raised to the power 2x minus this goes on the other side. So minus 32 into 2 raised to the power x plus 64 equal to 0. You will see this is the quadratic equation in, if I put y equal to 2 to the power x, it will become a quadratic equation. 3y square minus 32y plus 64 equal to 0. Such questions you would have come across in the quadratic equations chapter, because you know where the quadratic equation is not directly given, but you have to convert it to quadratic equation format. So if you would have known that, you could have, you would have been able to solve this question, because the concept of AP was very simple, but converting it into a quadratic equation was difficult. So the next part would involve solving the quadratic. So if you solve the quadratic, this becomes 2 factors of 3 into 64, that is 192, that add up to give you a 1 that add up to 32. So 192, let me think, 12 into okay, let me think of it that way. 192 is what, 96 into 2, or that is 3 into 64, or that is 48 into 4, or that is 24 into 8. 24 and 8 add up to 32. So clearly the split would be minus 24 minus 8. You change the sign, so that will be 24 and 8. You divide by the first coefficient, that is 24 by 3 and 8 by 3. So this is the answer of for the y. Y is equal to this. Therefore y is equal to 8 or 8 by 3. But y is what? Y is 2 raised to the power x. Okay, y is 2 raised to the power x. So if I put 2 raised to the power x over here, 2 raised to the power x is equal to 8 or 8 by 3. I'd get x is equal to 3 or x is equal to 3 or something. I don't know which value, which power of x will give me this. Okay, but the question is then x equals what? Okay, then x equals what value? Now this is slightly getting a difficult situation here. So if x is basically here x would be an integer, or x would not be an integer, so x would not be an integer. Okay, 2 raised to some number can definitely be 8 by 3, but that would not be an that would not be a rational value also. That would kind of be a very irrational number as well, or maybe rational number, but it won't be an integer value for sure. So the numbers this are in AP, then x equals what? So in any case, x equal to 3 is a value which satisfies this. If I put x equal to 3 in the middle terms, if I put x equal to 3, that will be 64 minus 32. So that is 32. 32 minus 16, that is 16. So minus 16, 16, and 32 plus 16, that is 48. So minus 16, 16 and 48. Yes, the three numbers are in AP when I put x equal to 3. and x has to be a natural number because we need integer answers in theta questions. I might have to take a look at the question. If the question included the word integer value of a, or maybe they mentioned that x is an integer value or something. Okay. Otherwise, this would become a little, little vague. Okay. But yeah, if that is kind of handled, then the answer should to this question should be 3. Okay. I think they might be, they might have given the condition that x must be an integer or something, but I'll have to check. I'm not sure because I don't see any other reason why the other value should not be considered. I hope I've done the calculation right. Just checking that bit once again. Minus 16. Okay. Yes, all the calculations and everything are also right. 8 common multiplied by 4, 32. Multiplied by 4, I have to take a 2. And multiplied by 4, it becomes a 64. The signs are right. Minus, minus, minus. And 2 to the power 2x minus 1. So for that reason, I've divided by a 2. Oh, I'm so sorry. No, wait. Yeah, I've divided by that 2 over here. I've accounted for that. Okay. So if such a situation crops up, which ideally should not happen in the actual paper, don't spend a lot of time on that. Go ahead and you can come back to it later. Okay, maybe if you're left with time at the end, right? Generally, if any question turns out to be wrong, either they don't consider it or they give marks for it to everyone. Okay, so you don't want to waste time on a question where you're getting stuck. But I'll just check this question up before jumping to any conclusion. Could be possible that I have made a small mistake, some small mistake here and there over here. Okay, so I'll also check on that. You can also try solving it once more. And this was about the short answer section of IPMAT 2022. The important point here that we had to understand was it was possible to attempt 10 or 11 questions. Easily 8 questions were around type A, and plus a 2-3 more questions could have been tried from the A/B question, and from those you had to get 7 or 8 correct as a good score. This is a good score. Good score would be something which which kind of justifies that okay, you've done really well in the paper. The cutoff was 20, so maybe even if the cutoff would have been 24, if you are aiming for a score like 32, you would have easily cleared that. Okay, so I hope this session was helpful. Thank you very much. The next session in this series would happen tomorrow again 7 to 9 p.m. and it would be QA MCQ section. So please solve it if you haven't done it already. The mock 10 is kind of closest to the actual difficulty level of the paper and is live now. So all IMS students are requested to solve the mock test also at the earliest. Don't keep it for too late. Okay. Anyone, any questions or any comments, please let me know in the chat, or you can just unmute and speak to me. Otherwise, we are done for today. Thank you very much. Thanks, Neil. Bye-bye.